You see, a lot of people think, well, I don't like any of those models, so I'm going to believe in the Big Bang. But you got a problem. Because you see, even if all those models were wrong, and other potential models as well, even if we didn't know how God got the light from those galaxies to the Earth, you can't use a light travel time issue to dismiss what the Bible teaches in favor of the Big Bang, because logically, you see, the Big Bang has a light travel problem of its own. A lot of people don't realize that, but the Big Bang has the equivalent of a distant starlight problem within its own model. And it doesn't actually pertain to distant starlight, but it is a light travel time problem. It's the same issue, and it's called the horizon problem. And the idea is that the universe, when it is very small, again, this is what the Big Bangers themselves teach. When the universe is very small, it has different temperatures in different places. Let's say A is very hot and B is very cold. Now, today, the universe is much bigger. It's expanded out. Today, we can look and measure the temperature in different places in the universe, and we find that the temperature of the universe, once you get out beyond sort of the furthest galaxies, the temperature of the universe is very, very uniform, very smooth, to 1 part in 10 to the 5th power, quite smooth. Well, there's a problem, though. You see, those 2 points, A and B, would naturally come to the same temperature if they could exchange radiation. If you put an ice cube in your hot coffee, you end up with lukewarm coffee, don't you? The ice heats up, the coffee cools down. They're in contact. They come to thermal equilibrium. Well, it turns out that there has not been enough time. Even in 13.7 billion years, there has not been enough time for light to get from A to B because those 2 places are so very far apart today, you see. And so this is a light travel time problem. How do you get light from A to B in less time than seems possible? It's a huge problem for the Big Bang, an enormous problem, because the universe is very, very uniform in temperature, very uniform. And so it's the equivalent of a distant starlight problem.